Okay, we're going to go ahead and work on this H.H. Scott Stereo Master 348-B solid state stereo. And what I'm doing is going through these PC boards and doing my best to account for the values and voltages. That actually broke. Values and voltages of all these caps on all the different ports. Got some over here. Let me put the light on it so you can see a little better. I got some on it over there. Those there. I've numbered the boards. You can see the number 4 there. 1. I believe this is 2. What did I write it? 2, 2, 3, 4. I didn't number it, but number 5 is down in the hole here. Okay. And what I did was I made up little packages. Number 4, which is the stereo decoder board, that one, I happen to have all these caps on hand. Never mind the antiquated values they used. That's a 47. I'm using a 47 UF at whatever I have, which is like 63 volts or something like that. There's the new caps. So number 4 is bagged and tagged. I've got everything I need to put a check mark on it. So this is good to go. This one here, I only had the 425 UF, so I still need a couple 47 UFs to probably get 100 volt rated radials. And I needed 250 volt. I think it's at 3 volt on the thing. Clearly I'm going to get 3 volt. I'll get whatever, it'll probably be 63 volts or 35 volts or something like that. Something that's approximately the right size. I mean, that's the main thing. I don't want it to be hard to fit into the holes. And I need to get the values reasonably close, of course, and the voltages should always be at least what was there or more, and typically a lot more in this day and age for the approximate same size of the parts. Let's see, board number 2, I'm missing a few there. I'm missing a couple 250s and a couple 100s, so that'll have to be gotten. And board number 1, I'm missing one axial lead cap that it uses. So the only parts I have a complete stack, a complete supply of, like I said, is number 4. So I'll be working on that. I'm going to be replacing this cap, this cap, this cap. I think it was just those 3. That's one reason why I had it. There just weren't that many to start with. For fun, I went ahead and pulled both these pulled this cap out, tested wide open. I mean, absolutely no indication of anything. It might have been a complete open circuit, so it's so dried out. I figured that would be the case. I'll probably check a few more of these as they're coming out just for fun. Not that I have any intention of keeping them, because I suspect that all these vertical caps will be bad. And what's the point? I don't know if these were replacements. These slightly different kinds. It's gray. The fact that it's an axial lead cap, I don't know. I mean, maybe that's what they had. I suspect this is probably more typical of the era. I also have a cap there. Now this is a 22, and there's a 22 over there. My guess is this is a replacement cap. That is, I'm sorry, I have a 22 here, and that's kind of unusual. That's a radial that's installed as a, I'm sorry, it's an axial installed as a radial. And over here, here's the other cap, this gray one, which also, is kind of odd that it would have a gray, not one of these black. So I have a feeling that both these were replaced at some point, and maybe at different times, because they're different styles. They're both 22. That's a 50 volt. That's a 35 volt. I don't know what's going on, but at least they're both 22, so I can assume that value is correct. Let's see, what else do I have on here to talk about? Oh, the last thing is going to be these tone caps down on this tone circuit. Now this is going to be a little bit of a challenge because, let me put this up. Okay, I mean, the access to these things is not going to be all that great. You can see it's kind of jammed up, kind of hard to get at. There's not much working space. And I believe that this PC board mount, I couldn't see any, I mean, some of the PC boards you can see mounting screws. See that screw there, right there? Getting screws to mount these boards. I couldn't see any screws on this bottom tone board. It's connected to the tone controls, bass and treble control. So what I think's going on here is, and I did notice that these pots are hard soldered into this PC board. Here's the pot connections. So my guess on this is they're using the fact that the pots are soldered directly to the PC board, and there's no evidence of any other physical mounting of the PC board to the chassis, makes me believe that it's actually the pot itself, the shaft of the pot, that's threaded to the subframe in here, the frame of the chassis. There's actually two nuts. There's the threaded part of the pot shaft. There's a nut that attaches the pot and therefore this PC board to the chassis, and then there's the faceplate that goes on, and then there's another nut after that secures the faceplate to the chassis. So I'll have to take the whole chassis off, take both those nuts off, so that this will then be freed up. And it looks like there's probably plenty of room here. I can just pull this away and get to work at it in order to replace those caps. And there's a whole boatload of them in there. I didn't do a count, but there's 1, 2, 3, 4, 5. So there's probably at least 10 caps in there that have to come out. Let's see if we can get better light on it. You can see how it's kind of tough to get at. The only thing that when I pulled the faceplate off that made it even slightly interesting was the fact that the meter, the signal strength meter, is soldered to some connections up here on the switch and whatnot, and it appears to be kind of held in with a glued in piece of tape or something like that. I'm not exactly sure what's going on there, but it definitely wants to stay attached to that faceplate. So it's kind of hard manipulating everything and with the wires attached to the meter. So I'm contemplating the best way of either removing the meter, which involves ungluing stuff, which I'm not real big on, or just unsoldering it, which I'm not real big on either, because I don't really like fooling around with the solder connections of these old meters. That thing breaks, I'm screwed. So I'm thinking about maybe finding where the wires go to the meter and either unsoldering them from the switch, which is another thing I don't really like to do, or I might even go so far as just to literally cut the wire and just resolder it, put some heat shrink on it when I'm done, or maybe even just put a quick connector on so I can just disconnect it if it ever has to be serviced again. You can pull this front panel off real easy if you don't have to screw around with the meter. So a quick disconnect would be a little bit of overkill of work, but it would certainly make servicing this thing a million times easier in the future. So I may just do that, But I think the thing's worth salvaging, so I'm going to go ahead and work on it. The one thing I haven't tested at all are these caps, these big can caps. I suspect they're going to be okay. I can test them. I'll have to check the voltage ratings to see if they're high enough. Let's see if I can read it. 65 volts DC on one of them. I can read that for sure. This is why I was looking for the schematic, because some of these things are pretty hard to read. 65. Yeah, so both of these are 65 volts anyway. So that's within the range of my old school cap tester. When I say that, I'm talking about this thing. That's 25 volts. Well, I'll tell you what, if it works, if it doesn't leak at 25 volts, it's probably okay. I don't want to jump up to 150. That would not be a good idea. These Heath kits typically put out 50 volts on a 25 volt scale, but I actually modified the voltage divider so that it's truly 25 volts. Maybe that wasn't such a smart idea now. It would have been better if it was at 50. But you get the point. An alternate approach would be to simply, test it for capacitance using the bridge, make sure it's 2000. Oh, that's going to be off the scale anyway. This is really not good. Okay. Well, I don't know what I'm going to do to test those big caps. I don't usually, like I said, I don't usually do solid state stuff, so I don't usually have high voltage or low voltage, high capacitance caps to test. So I'm not sure what I'm going to do. I could test it for leakage easily enough. I could just put a DC power supply on it and use that to charge it up and you know, see if it leaks out. You know, I could check the current flow, and it should drop down after it's fully charged. That can test leakage, but I'm not sure how to check for 2,000 volts. My bridge only goes up to 1,000. I'm not smart enough to figure out how to do that. Check it to 2,000. I'm assuming that, you know, you can probably tell just by seeing how long it takes the cap to charge up, give you a pretty good idea of the capacity of it. So I guess I could do something along those lines. I'm going to think about this a little bit, but I'm really in no hurry to go out and start replacing these things. Like I said, it's been my experience that these cans often hold up. They end up getting replaced for no good reason, and I just don't like to do things. I don't like to replace things that are perfectly good. If it doesn't test really well, though, if I can devise a good test procedure, I'm not adverse to replacing them. But what I'd probably end up doing is removing the caps and restuffing them, because I just don't like putting stuff on the bottom. I know a lot of people do that, and certainly room to do that, but that's just not my style. I think I've covered that before in some of my other videos, how I like to have the lead dress all original so everybody knows what's going on. That's just me. I don't really have a beef with people who choose to put under a chassis. I mean, that's perfectly acceptable. Sure, it was how it was done back in the day, and well, I was done back in the day, they would have had the right part, but you know what I mean. It's certainly an acceptable approach to simply go under the chassis, and you could just, let's see, where's this go? And a couple of things you could do. You could find out where this goes to, and maybe make a direct connection to it, or you could just put a terminal strip in here somewhere and mount the terminal strip and mount the under chassis. It's a little bit crowded in here, though, to tell you the truth, to be sticking a big old couple 2,000 UF caps in there. So, I mean, it could be done clearly, but that's just not my style. I mean, these, let's see, God, they didn't even solder it. That is surprising. Holy smokes. You know something? Oh, wait. Barely? Hang on, look at this. That's kind of surprising to me. These twist lock caps are not soldered in at all, anywhere. So they're only relying on the ground to come through based on the tabs being twisted over coming into contact with the steel chassis. That's really not very, I mean, it's going to make my job a lot easier because it'll be very easy to remove these caps, but that's really not correct. I'm kind of stunned to see that. I mean, typically what you would do is you would take at least one of these tabs and, you know, flex it up and get a big soldering iron on it and get a good solid ground connection there. That could cause a very low resistance, a very low resistance leakage point between the cap and the ground on this chassis like that. That's kind of surprising. There's another cap I got to replace. I didn't even see that one. I got that one there. Like I said, these polyester caps look kind of jacked, and I have no value. I can't tell what the value is. It's the plastic that had their value written on it. My hope is that A, they're okay, and B, if they're not okay, at least one of these is okay, because I'm thinking this is like a stereo setup, so I'm assuming that these values are just, I mean, I don't really know. I don't know what to do here. If I can't figure out what the value is, it'd be kind of silly to start replacing stuff I don't know. That's going to be a little bit of a problem. I really hope they just, I might take them out of the circuit and see if they're shorted. If they're not shorted, then they're fine, you know. That's pretty much the way it's going to have to go. And I could take a guess at it's going to be somewhere. It's a pretty big cap. It's pretty low voltage. I'm guessing it's going to be anywhere from a 0.047 to a 0.22, you know. So that's a little bit of a problem. Anyway, I've got a game plan. More later.